Welcome, this is Coach Dorff again. We're in section 1.5 and we're going to look at another example of a problem that's similar to homework. In this one, we're supposed to simplify the tangent of the inverse cosine of 2/3. So let's remember what the inverse of a trig function means. So if I have the inverse trig function of 2/3, what's that going to look like? Well, it should be an angle. So for example, if I had a triangle here, and let's say this angle is theta here, we're to give some sides here. Let's say this is A, B, and C. I know the cosine of theta is the adjacent over the hypotenuse, which in this case would be A over B. If I'm doing the inverse cosine, I'm then going to write the inverse cosine of A over B exponent there means it's the inverse cosine function, or the arc cosine function. If I want to do 1 over cosine AB, then I would do cosine of AB with the square brackets around everything like this, and then put everything to the -1 power. That would be the equivalent there. So don't make those mistakes there. So in this problem here, we have the tangent, and then we have the inverse cosine of 2/3. So the inverse cosine should be an angle. Now, if the inverse cosine is something that we already know, then we can use that fact. For example, what's the inverse cosine of 1/2? Well, it's going to be an angle. It's going to equal an angle. And what angle does it represent? Well, that's going to be the same thing as saying what angle, I'm going to give the angle a name theta, what angle theta gives the cosine of that angle equals 1/2. And now it has to be within the domain of the trig function. So for the inverse cosine, we know that my domain is going to be between 0 and pi. So my angle has to be between 0 and pi. If I go beyond that, then the function values repeat and I can't do an inverse function. I have to have a one-to-one value. So what value theta, if I take the cosine of that theta value, I get 1/2, where theta is between 0 and pi. In this case, then this tells me that theta equals pi over 3. So the inverse cosine of 1/2 equals pi over 3. And there are certain values that I can figure out the inverse cosine. So I could do the inverse cosine of 0. I could do the inverse cosine of square root of 3 over 2. I could do the inverse cosine of square root of 2 over 2. And I could do the inverse cosine of 1. Those are some of the values that I could figure out. Just as an example here, the inverse cosine of 0 is pi over 2. The inverse cosine of square root of 3 over 2 is pi over 6. Inverse cosine of square root of 2 over 2 is pi over 4. And the inverse cosine of 1 is 0. All right. But in our problem here, we have the tangent of the inverse cosine of 2/3. And 2/3 is one that we don't know the value of. We don't know what the exact value of the inverse cosine of 2/3 is. So you might say, well, Coach Dorff, then how can we solve this problem? Well, we're going to do the following. We're going to make a triangle. We know that the inverse cosine of 2/3 is going to equal an angle. So let's just call that angle theta. And I draw my triangle. I'm going to put the angle there. If the inverse cosine of 2/3 equals theta, that's the same thing as saying the cosine of theta equals 2/3. So let's apply that to my triangle. So if I have the triangle with the angle theta there, cosine is adjacent over hypotenuse. So my adjacent side is 2, my hypotenuse is 3. And then I can use Pythagorean theorem to figure out what the value of the opposite side is. So by Pythagorean theorem, we have 2 squared plus b squared equals 3 squared. And that means I'm going to get 4 plus b squared equals 9, b squared equals 5, or b equals square root of 5. So when I have this tangent of the inverse cosine of 2/3, I know that that's just going to be the tangent. Well, what is the equivalent? What does this equal? That equals theta, because that's what we have right here. So that's going to be the tangent of theta. Well, what's the tangent of theta? Well, now I go back to my triangle here, and I know the tangent is the opposite over the adjacent side, and that's going to give me square root of 5 over 2. And that's my answer. Hope that helps.